Okay, 7 part 4, rotation of conic sections. Well, now what this means is you're going to take a standard conic section, same ones we've discussed, ellipse, circle, parabola, hyperbola, and rotate them where they are not parallel or perpendicular to the x-axis. So we're going to rotate them through some angle theta, and they're going to be askew with respect to the angles. So some formulas you need to know are these, and I'll tell you what page they're on so you don't have to bother copying all those down. This is going to be a bonus question on the test, but it's worth 10 points. And that's a pretty good amount of points. In fact, you can make 110 on the test if you got this one right. And some of you guys need 110 on the test like the desert needs rain. So I would certainly not ignore this. So this is on page 457. These formulas, page 457 in your text. And also 455. Well, yeah, there's 3 pages with formulas. 454, 455, I think, are these 2. 454 is just this bit. So there's several formula pages. This one's 454. I see that we're going to have to slow the flow of the bathroom usage here, because I'm not going to listen to that all day. Okay, so this is the next formula. This is on page 455. So this is how we find theta using the coefficients of the conic. So A minus C over B is cotangent to theta. So we use that to find the theta, eliminate the xy term, use new axes. So if you have a B term, you remember I told you the standard form for all conics was ax squared plus bxy and so on. When this term is not 0, that means you have a skewed conic, one that is not perpendicular or parallel to the x-axis. So when this B term exists, this is when you got a problem. And you can use this formula to find the theta and then redefine the axes. So let's just say, for the sake of argument, you've got one that's like this. So this is x-axis. This is the y-axis. It's clearly skewed to them. But I can create some new x prime and y prime axis that it is perpendicular or parallel to. Do you see what I mean? So we're going to rewrite this in terms of x prime and y prime, where it is a conic that is not skewed to those x prime, y prime axes. And the formulas I showed you on the last 2 pages accomplish that. Okay, so here's an example. Now, theta equals 90 is kind of boring, because you see how that just switches the x and y axis effectively. So that's kind of boring. But this one is a good little quick practice. So we've got x and y related to each other in this way. X squared plus 3xy minus y squared equals 3. And I want to rewrite it in terms of the x prime, y prime plane using these formulas. I need to find my theta first. So to find my theta, I need to know the cotangent of 2 theta, remember that was on that previous page, is A minus C over B. So A in this case is 1, B is 3, and C is -1. So B can't be 0 for this to work, because otherwise you'd have division by 0. So I've got 1 minus a -1 over 3. Now they tell us, actually They don't even want you to use that theta. They want you to use this theta. So, but this is the mechanism we would use to find that angle that makes it not skewed. But that's not the task here. This is what we would have done if that were the task. The task instead is to just use theta equals 90. Again, kind of boring. So we would have used that other way if we really wanted to make the conic into a non-skewed conic. But we'll just meet the brief here. So x equals x prime cosine of 90 degrees minus y prime sine of 90 degrees. Plug it in here. So x equals the cosine of 90 degrees. That's the x coordinate is 0. You guys remember the unit circle? So dust off that memory. 90 degrees. The cosine is 0. So this term becomes 0. Minus, and then y prime sine of 90 degrees is 1. So x equals negative y prime. Almost trivial. And then y equals x prime sine 90 degrees plus y prime cosine 90 degrees. Once again, that second term just becomes 0. So x prime times the sine of 90, that's just x prime plus 0. So y equals x prime. And we'll plug these in. So this is just kind of to get you used to fooling around with those formulas. We didn't really accomplish anything substantive here. So x equals y prime negative y prime. So that little superscript tick mark does not mean to the first power. It means a different y. The new y rotated 90 degrees in this case. However, if we're really trying to solve these problems, it would be rotated some degrees that would make it not skewed. And then y just equals x prime. And so there's our result. Could simplify that a little bit, but because again, this is just to get you looking and thinking about those formulas, that task is done, and we'll move on to the real problem. All right, real problem here. This is it. Oh yeah. So now what we want to do is we want to eliminate the b term. So the task, the first time was just to take some arbitrary theta and rotate the conic. Not a lot of point there. This time we're going to rotate the conic a very specific way that will eliminate the b term. So we need to find theta that eliminates this b term, gets rid of it. So I'm going to rewrite this in terms of x prime, y prime, where that b term does not exist. And this formula is going to give me the theta that will accomplish that. It's going to give me the perfect angle that makes this a non-skewed conic. All right, so let's see. A equals 13, B equals negative 2 on the square root of 3, and C equals 15. Are you with me on that? Remember, A, x squared, B, xy, C, y squared, dx, e, y, and then f. That was the standard form for all conics. That's where I'm getting the A, B, and C. That was from the previous section, very end of 7 part 3. So cotangent of 2 theta equals A minus C. So that's 13 minus 15 over negative 2 on the square root of 3. And so that's negative 2 over negative 2 on the square root of 3, or just 1 over the square root of 3, or radical 3 over 3. So I need to use a tangent inverse. So cotangent of 2 theta, cotangent is not on our calculator. So I know if the cotangent of 2 theta is that, the tangent of 2 theta would be the reciprocal, which is just radical 3. And then if I take the tangent inverse, I'll get this relationship. Then if I divide both sides by 2, I'll get this for theta. Tangent inverse of the square root of 3 divided by 2. So let's see what we get. Tangent inverse of the square root, what in the world? The square root of 3, and then divide that by 2, and I get pi over 6 or 30 degrees. So the theta that's going to make this happen is theta equals pi over 6. Need to slow down the bathroom usage. Next person staying out there the rest of the period. Okay, so we found theta equals pi over 6 is going to accomplish our task. Get rid of that b term. Now we're going to plug that in here. So x equals x prime times the cosine of pi over 6 minus y prime times the sine of pi over 6. Remember your unit circle. Pi over 6, that's that 30 degree mark. The x coordinate, the cosine, was a square root of 3 over 2. The y coordinate, the sine, was 1/2. So we're going to plug that in from the unit circle. And then, so we get this. So there's our x that we're going to substitute in to our equation. And now we're going to do the same thing with y. Make that a little bigger. So y equals x prime sine pi over 6 plus y prime cosine pi over 6. Remember the sine of pi over 6 is 1/2. Cosine is radical 3 over 2. So we get y equals 1/2 x prime plus radical 3 over 2 y prime. Okay, so we're ready to go now. We've got the things we need to substitute. And we need to plug in into our original equation this expression for every y. You guys with me? And then this expression for every x. Sounds simple. It's going to be a lot of algebra. But from this point forward, it's just algebraic operation. Just like expanding, combining like terms, etc., etc. There's no tricky bit to the problem after this. Just a lot of tedious work. So if you can get to this point, you're flying. Okay, so let's see. Let's rewrite this, and I'm going to shrink my work over here so it's not in the way. That was where we found our theta. Idea what's going on there. Okay, now we're ready to do the real work here, which is, and this is going to be on multiple lines. I try to confine myself to a single line with most problems. Not possible here. So this is going to extend down several lines. Be prepared for that. All right, so 13 times, instead of x, radical 3 over 2, x prime minus 1/2 y prime squared minus 2 on the square root of 3 times x again, radical 3 over 2 x prime minus 1/2 y prime, and then times the y value, which is 1/2 x prime plus radical 3 over 2 y prime, and then plus 15. And I'm going to work exclusively with the left side of this, okay, for now, because this 96, I don't need to simplify that any further. So I'm exclusively working with this expression on the left side. It's where all the x and y's are anyway. And then I'll plug it back in at the end when I do my final simplification, okay? So I'm taking only the left side of this equation and simplifying it. So
multiplication sign.
Yes, yes. So 15 times y squared, which is 1/2 x prime plus the square root of 3 over 2 y prime, like 7. So this is just the left side of that equation rewritten using this x prime and y prime expression that's going to rotate that conic in such a way that it's no longer skewed. The b term is going to disappear if we do our task right. So this is possibly one of the more challenging algebra situations you've ever seen in your life, but we can handle it. So I'll change colors every time so you can more fully understand what is what. So the first thing we're going to do here is expand this, okay? So we're going to use FOIL. So this is just this times itself, okay? When I square a binomial, I'm multiplying it by itself. So first times first would just be this squared. So that's square root of 3 times square root of 3, which is 3, over 2 times 2, which is 4. And then x prime times x prime is x prime squared. Now be careful when you square a prime. You see how I superscripted the 2 even further above that tick mark? So it doesn't look like x to the 12th. So be careful with that. That's a potential notational error you could make. And then outer times outer. So that would be this times this. It's going to be negative square root of 3 times 1 over 2 times 2 is 4. And then x prime, y prime. That's outer times outer. We're still working with this. And then inner times inner will be the same thing. And then last times last would be this times itself. So that's positive 1 over 4 y prime squared. We use a little highlighter action. Going to need a lot of different highlighter colors for this problem. So just this bit, when I expand it, became this bit. Okay?
Is that 1/4 at the end?
1/4 y prime squared, yes. So just this bit became this bit. We ain't even close enough. So we still got all this other mess, but we'll get to it. Don't worry. Slow and steady is the key here. All right, so minus, and then this times this. We're going to FOIL again, but I've got this 2 on the square root of 3 that's going to be multiplied by whatever this FOIL works out to be, so I can't forget about him. First times first, so that's square root of 3 over 2 times 1/2, which is radical 3 over 4, and then x prime squared. And that's first times first. Now outer times outer. So square root of 3 times the square root of 3 is 3. 2 times 2 is 4. And then x prime y prime. So that's outer times outer. Inner times inner. Going to be negative 1/4 x prime y prime. So negative 1/4 x prime y prime. That's inner times inner. And then last times last, negative radical 3 over 4 y prime squared. Double check yourself. Nothing worse than making a mistake on a problem like this early, because guess what? Everything you did after that, chalk. First times first looks good. Outer times outer, looks good. Say again, sir. That's all right. I do that too. That's what I'm doing now, in fact. Inner times inner. Looks good. Last times last also looks good. Okay, cool. So more highlighter action. We choose a new interesting highlighter color. This weird green would probably work. So this whole bit became this when I expanded it, okay? And you need to keep track of what's what or you're gonna get lost here. All right, now the last one, which has a coefficient of 15. And it is this quantity squared, which again is just that times itself. First times first, this times itself, 1/4 x prime squared. And then, a little too much like a y. There we go. So 1/4 x prime squared is first times first. Outer times outer would be this times that. So that's radical 3/4 x prime y prime. Inner times inner would be that. Inner times inner would be that again. And then last times last would be this term times itself. Square root of 3 times the square root of 3 is 3. 2 times 2 is 4. Y prime squared. And so now, and actually left off a bit here. That's part of that middle term. Pick a new highlighter color. Let's do it's like periwinkle. You guys remember crayons when you were a kid?
Periwinkle.
I think that's called periwinkle. The only reason I know that is Crayola. I can't tell one color from the other usually. Actually, that's a little, I don't like that, it's too dark. Let's see if I can lighten that up a bit. Okay. All right, so I'm gonna go down to like 50%. So you can see this step and this step. All I did between here and here was expand all those squared terms in the case where the binomial times the binomial happen. That's all I did so far. Now I'm gonna distribute the scalars. You see everything has something on the outside. I'm gonna distribute that to the terms inside. So that's my next step. And this is arbitrary. You don't have to do it in the exact order I'm doing it. This is just what occurs to me. In fact, I've got saved examples of me working this problem like 50 different times. And in every case, I did something a little different. So there is not one way to do it, in other words. Okay, so let me get the blue pen now. So this is going to be 13 times 3, 39/4 x prime squared. And then if I combine these two terms, well, I'll wait and do that next. So minus 13 on the square root of 3/4 x prime y prime minus 13 on the square root of 3/4 x prime y prime, and then plus 13/4 y prime squared. So that's distributed in the 13. That's all I did. And then minus, well, I'll tell you what, let's distribute the minus sign along with the 2 on the square root of 3. So I'll make it a plus, because I'm distributing that minus sign. Just make our lives easier. So that's 2 on the square root of 3 times the square root of 3. Minus 2 on the square root of 3 times the square root of 3 is minus 2 times 3, or minus 6/4. Square root of 3 times square root of 3 is 3. 2 times 3 is 6. And then this negative sign is going to get distributed with it. And then plus, so that's minus 6 on the square root of 3/4 that right? Yeah. X prime, Y prime. And then negative times a negative will be positive. So those negatives will cancel out. And it's positive 2 on the square root of 3 over 4. X prime, Y prime. And then negative times a negative again, those will cancel out and become positive. Square root of 3 times square root of 3 is 3. So positive 6 over 4 Y prime squared. See how easy it would have been to make a sign error there. So easy. So easy to the point where it's almost inevitable that you would have done so. All right, so last one here, this 15 we need to distribute. So plus 15 over 4 X prime squared plus 15 on the square root of 3 over 4 X prime Y prime plus 15 on the square root of 3 over 4 X prime Y prime. Yep. Plus 15 times 3 is 45 over 4 Y prime squared. Okay, so we're really getting somewhere now. Combine like terms, this will start to get simpler. We're at the top of the mountain. We're ready to come down. Now we combine like terms. So taking that first one, I need to change pen colors so that you guys know this is a distinct bit. I'll do purple here. Okay. So that's going to equal, so I've only got one X prime squared term in this first one. But I've got these two in the middle, so I need to combine those. That's minus, and I'm going to leave it over 4 for a reason. So we could make it 13 over 2, but I'm leaving it over 4 because later on we're going to need common denominators anyway. Just going to save us a step later. You wonder why I'm not fully simplifying here. So this is minus 26 on the square root of 3 over 4 X prime Y prime, and then plus 13 over 4 Y prime squared. Now the second row, so that's going to be plus negative 6 over 4 X prime squared. Then I've got minus 6 on the square root of 3 plus 2 on the square root of 3. That's going to be minus 4 on the square root of 3 over 4. The 4's cancel, so that's just minus the square root of 3. Well, I'll leave it in that 4's because, again, we need like terms. So minus 4 on the square root of 3 over 4 X prime Y prime. Yeah, minus 6 plus 2 is minus 4. And then plus 6 over 4 Y prime squared. Now the very last one, we're going to combine those like terms. So 15 over 4 X prime squared. And then combining these, I get plus 30 on the square root of 3 over 4. X prime, Y prime. And then plus 45 over 4 Y prime squared. We're really close now. It's starting to get just a little bit simpler. All right, new pen color because we're on a new step. Ugly green. That'll work. So what I'm going to do now, do you see how, I'll try to use some unique highlighter colors here too. Do you see how all of these are times X prime squared? So I can use that to say like this. Does this make sense to you guys what I'm doing here? I took all the x squared terms and just wrote them as a single term. So I'm combining like terms. All these x prime squared terms, I'm written here in one place. I'll do the same, of course, with the others. All right, back to the pen. So plus, and now we're going to use the coefficients of x prime, y prime. Minus 26 on the square root of 3 over 4. Minus 4 on the square root of 3 over 4. Plus 30 on the square root of 3 over 4. X prime, y prime. Now we're getting excited because guess what? Remember our whole task was get rid of that b term. You notice an interesting relationship between these three values? They're all going to cancel out. So we know we're on the right track. Anything other than that at this point, you screwed up. Unless these go to 0, you screwed up. But I see that they do. So yes, we're in good shape. Now the y terms. So plus, or y prime squared terms, I should say. 13 over 4, 6 over 4. Plus 45 over 4. All right, new step, new pin code. Let's do orange for the Cyclones. They're going to win tonight.
Where they playing?
Sullivan Central, the last game ever for that school in their school's history. Yeah, because that high school is being dissolved by the Sullivan County school system. So if I add these up,
Rip Central.
indeed, 39 minus 6 is 33, plus 15 is 48. Everybody with me? 39 minus 6 is 33, plus 15 is 48 over 4. X prime squared. Plus negative 26 minus 4 is negative 30 on the square root of 3. Plus 30 on the square root of 3, 0. Oh yeah, look at that. X prime, y prime. That term is gone. And then here, 13 plus 6 is 19. Plus 45 is 64 over 4. Y prime squared. Then, of course, this term we can get rid of in the next step, and we can reduce this. So we were working exclusively with, let's see, let me change colors once more. Running out of colors. Red, well, used red earlier, didn't I? Maybe like this, but make it real dark. That'll be interesting. Okay, equals. What's 48 divided by 4?
12.
Yeah, 12x prime squared, and then 64 divided by 4. 16. Good. Plus 16 y prime squared. Now we're ready to go back. You remember originally this mess was equal to 96. So here we go. I'm going to set this now equal to 96. And now I'm going to move it to standard form by dividing away 96. And on this very last step, I'll just use a calculator to make our life easier. 96 divided by 12 is 8. So that is x prime squared over 8 plus 96 divided by 16 is 6. That's it. That is the modified ellipse that is no longer skewed. The B term is gone. We can move it to standard form. Because they're happy again. And in record time, only about, I don't know, 25 minutes.
Are there gonna be more from?
Nope, that's it. That's the one that broke my student teacher one time.
This one.
Just broke him. And I can see why. It's a messy problem. So this is virtually identical to the one you'll see on the test as a bonus in length, not of course in formulation, because that would be trivial. I'm never going to task you with copying something down. That's an insult to your intelligence. So it'll be the same level of challenge. And it will require all those steps. So this is a video you may want to consult. All right, so that's chapter 7, part 4. Let's move on to chapter 7, part 5. Stop the video and restart it.